Hey everybody, welcome to Module 4.2 in Unit 2. Today we're going to go over the specialized structures of the integument. Again, you can see the learning outcomes here. Remember, those are directly correlated to the study guide that you'll get for the unit exams, as well as goes into helping me develop quiz questions for this unit. All right, so we can get into pigmentation. So some of the factors that affect skin color include epidermal pigmentation and dermal circulation. The color of one's skin is genetically programmed. However, increased pigmentation or tanning, as a lot of you would know it as, can result in a response to ultraviolet radiation. Right. Skin color, as such, is going to be influenced by the presence of pigments in the epidermis. So you have melanin, which is a brown, yellowish brown, black pigment that's produced by melanocytes, and you can see those here. And melanocytes are located within the stratum basale and squeezed between or deep to the keratinocytes. Melanocytes manufacture melanin from the amino acid tyrosine and package it into intercellular vesicles called melanosomes. Melanosomes would then travel within the processes of the melanocytes and are transferred intact to the keratinocytes. And then the transfer of those pigmentation colors of the keratinocytes temporarily, or at least until the melanosomes are destroyed by fusion with lysosomes. So an individual with pale skin, this transfer occurs in the stratum basale and the stratum spinosum, and the cells of more superficial layers lose their pigmentation. In dark-skinned individuals, the melanosomes are larger, and the transfer may occur in the stratum granulosum, and as such, the thick skin and the pigmentation is darker and more persistent. And the skin covering most areas of the body has about 1,000 melanocytes per square millimeter, and differences in skin pigmentation among individuals do not reflect different number of melanocytes, but instead the different levels of melanin production. In addition to that, we have carotene, which is an orange-yellow pigment that normally accumulates in epidermal cells. It's most apparent in cells of the stratum corneum of white-skinned individuals, but also accumulates in fatty tissues in the deep dermis and hypodermis. Okay. Carotene is also found in a variety of orange and yellow vegetables. Think sweet potatoes, carrots, and squash. In addition to that, the blood supply affects skin colors because blood contains red blood cells filled with the red pigment hemoglobin. And when bound to oxygen, hemoglobin is bright red, and that gives capillaries in the dermis a reddish tint that is almost apparent in light-skinned individuals. And if those vessels are dilated, the red tones become much more pronounced. For example, if your skin becomes flushed and the red within your body temperature rises because the superficial blood vessels dilate so that the skin can act more like a radiator and lose some heat. You also have a few other things that can affect that, such as when blood flow decreases, oxygen levels in the tissues decline, and under these conditions, hemoglobin releases oxygen and then turns a much darker shade of red. So seen from the surface of the skin, takes on a bluish color. We call that coloration cyanosis. So in individuals of any skin color, cyanosis is most obvious in areas of very thin skin. Think the lips, under the fingernails, things like that. So skin has several accessory organs. Among those include nerve fibers, corpuscles, hair follicles, all the things we talked about at the beginning. So hairs. Hair follicles are a complex structure composed of epithelial cells and connective tissue that are responsible for the formation of a single hair. So the hair follicle has three regions. You have the internal root sheet, the external root sheet, and the glassy membrane. Okay? Hair production begins at the base of the hair follicle, and here a mass of epithelial cells forms a cap, which is called the hair bulb, that surrounds a smaller hair papilla. And that's the peg of connection tissue between the capillaries and the nerves. So you have the root hair plexus, which are some sensory nerves that surround the hair bulb and give the hair the ability to detect touch. And associated with each hair follicle is a bundle of smooth muscle cells called the arrector pili muscle. You can see that here. And these muscles will contract and cause hairs to stand up or become erect. It's also the muscle responsible for goosebumps. The human body has about 2.5 million hairs, and about 75% of them are on the general body surface and not on the head. Hairs are non-living structures and composed of keratinocytes. So again, we have a few parts of the hair. You have the hair shaft, which is the portion of the hair that extends through the follicle and protrudes above the skin line. So that's here, the hair shaft. You have the hair root, which is here, which is the portion that anchors the hair to the skin. You have the cuticle, which forms the surface of the hair. It's composed of hard keratin. So that's here. You have the cortex, which is an intermediate layer of cells deep to the cuticle, and it contains thick layers of hard keratin, which gives the hairs their stiffness. You have the medulla, or the core, which consists of cells at the center of the hair matrix and filled with a soft keratin. And then you have the hair matrix, which consists of the superficial cells of the hair bulb. And these germinative cells in the hair matrix help to produce the hair. You also have variations in hair color that reflect differences in hair structure and the variation in pigment produced by melanocytes in the hair papilla. Different forms of melanin give a dark brown or yellow brown or red color to the hair. So as pigment production decreases with age, hair color tends to lighten, and white hair is a result of the combination of the lack of pigment and the presence of air bubbles in the medulla of the hair shaft. Moving on to nails. These are thick sheets of keratinized epidermal cells. Nails help to protect the exposed dorsal surfaces of the tips of the fingers and the toes, and they also help to limit the distortion of the digits when they are subjected to mechanical stressors. The cells producing the nails can be affected by conditions that help to alter the body metabolism, so changes in the shape, structure, or appearance of the nail can provide useful diagnostic information to help you kind of diagnose what's going on. So you have several parts of the nail. Oh, I'm sorry about that. You have the nail body, which consists of dead, tightly compressed keratinocytes packed with keratin, and the nail body is the portion of the nail to which the polish might be applied, so you have that here. You have the nail bed, so the nail body covers an area of the epidermis that contains a rapidly dividing cells that divide to help replace cells that are lost. Again, remember these are exposed to several mechanical stressors and chemical stressors, so they always reproduce and very quickly. You have the nail root, which is the epidermal fold that's not visible from the surface and helps to anchor the nail into the underlying tissues. And the deepest portion of the nail root lies very close to the bone of the fingertips. You have the hyponychium, which is the free edge of the nail, and it's composed of a thickened stratum corneum, which is the distal portion that continues past the nail bed, and the eponychium, which is a portion of the stratum corneum of the nail root that helps to extend over the exposed nail and is more commonly called the cuticle. So that here. So we already talked a little bit about glands and the last things that we did. You might find this slide a little familiar. This was in the tissue section, as was this. So make sure that you read up on these and kind of remember because it'll come back in this section. But as we move and get a little bit more specialized into this unit, you have what are known as sebaceous glands, and these are your oral secreting glands. And they're essentially simple alveolar glands that are found all over the body except on the palms and the soles. So sebaceous follicles secrete onto skin surfaces and are located on the face, back, the chest, the nipples, and the external genitalia. Okay. Contractions of the erector pili muscle, which remember that's that muscle attached to the hair, squeeze the sebaceous gland and force out the sebum, which is a mixture of triglycerides, cholesterol, proteins, and electrolytes onto the hair follicle and onto the skin surface. And these glands are the holocrine type, which if we go back, you can read that the holocrine type cells will kind of fill up with oil and then they'll burst open. Sebum is secreted onto the hair follicle or occasionally onto a pore or a follicle onto the skin surface, and helps to soften and lubricate the hair and the surrounding skin, and also has some antibacterial properties. In addition to sebaceous glands, you have sweat glands, which are distributed all over the body surfaces except for the nipple and parts of the external genitalia and the lips. You have several different types of sweat glands. You have your eccrine sweat glands, which are the merocrine type, and these are very numerous in the palms, soles of the feet, and the forehead. Your eccrine sweat glands are commonly called sweat. Okay. And they are a hypertonic filtrate of the blood that helps to pass through secretory cells of the sweat glands and release by exocytosis. So that's what sweat is. Once released, the sweat travels via a duct to the surface of the skin where it then opens into a funnel-shaped pore. Normal pH of sweat is about 4 to 6, which gives it some antibacterial properties as well. In addition to those, you have your African sweat glands, which are largely confined to the axillary and the anogenital sections. And these are larger than eccrine sweat glands and release their secretions onto the hair follicles. The secretions then that are produced are similar to sweat, but they also contain some fatty substances and proteins. And then the apiarine glands begin functioning at puberty. You have your ceremonous glands, which are some modified apiarine glands that line up to the external ear canal and secrete a sticky, bitter substance called cerumen, which is also earwax. And then you have mammary glands, which are specialized apiarine glands that secrete milk. You also have several sensory receptors in the skin. Okay. You have what's called free nerve endings, which are numerous unencapsulated nerve endings that help detect pain and temperature. You have tactile discs, which extend from the dermis into the epidermis, where they connect to Merkel cells and monitor some chemical secretions. You have tactile corpuscles, which are also named Meissner's corpuscles, which are receptors located in the dermal papillae, and they're responsible for detection of light touch. You also have lamellated corpuscles, or Pansini corpuscles, which are located in the reticular layer of the dermis, and they're responsible for detection of deep tissue and vibrations.